message. The future is not set.
It's working now. Okay, so my name is Roman Eng. I'm an academic researcher, and my day job is actually I'm a director of compliance. I'm working on my PhD in safety and alignment. I do have an AI SIG. I'm based in Chicago, so I have an AI SIG that I run. So feel free to look me up. We have quarterly meetings. So the world presents some amazing patterns. To us, it looks like chaos. But we have natural laws that govern them. We have agents that independently operate seamlessly. In the AI field, we have the hubris of thinking that we can model the real world. And that's what we intend to do. And these are in the form of algorithms. The interesting thing is that complexity does not equal chaos. It basically just limits our ability to predict. And that is what we're challenged with day in and day out. So I wanted to show you something real. So this wasn't AI generated. This is actually a book that I bought about 6 years ago when I got back into AI. And it actually pulls from several ideas. Ideas like the symbolist, which they love rules and logic. The connectionist, it takes the inspiration from our brains, the ways that neurons are connected and how things are connected in real life. We have the evolutionists. Something has an origin and they emerge. And then lastly, we have the Bayesianists, which it's all about probabilities and predictions and the causal effects. So the book goes into an idea of, is there a master algorithm that governs them all? That is a profound idea in a sense. To have one algorithm that can solve all problems. So what I'm going to walk you through is I'm going to walk you through some commonalities in complex algorithms. And we're going to have a little fun with it. So I am from Chicago, so thank you. So in the 1920s, prohibition set in. We had a savvy businessman from New York. He actually seized the opportunity to actually bring his business to Chicago. He became public enemy number one. And what I can say is that we had a really hard time, and there was no solution to actually stop him. If you see from just some of the graphics, he made about $100 million a year, which equates to about $1 billion today. He actually moved 1 million gallons of liquor during that prohibition era. He had diverse businesses. So not only did he bootleg, but he was in gambling, prostitution, and a number of nefarious activities. He actually utilized a very complex system 60 miles of underground tunnels, some of which still exist today. And lastly, he had this dynamic network that basically threw a wrench into trust, because the question is, he bribed his way through a lot of officials. So the question is, how do you stop a network like this? So since we're at a cybersecurity conference, I figure I'd give you this algorithm. So for 50 years, since the 1970s, since ARPANET, this field has emerged. Some would say that we have a very mature field. But as you can see, we are still grappling with a lot of issues. This is a bold statement. I don't see a foreseeable stop to these cyber threats. If you look at how much we're projected to spend in terms of stopping these cyber threats, it's insane. Just to give you some perspective, the GDP for the US is 27 trillion. We're probably going to eclipse 10.5 this year. And look at the zettabytes of data. The amount of data that we have to protect is going to exponentially skyrocket because, thanks to artificial intelligence, we are generating a massive amount of synthetic data. And we actually project that over 95% of the data that's out there on the internet is going to be synthetically generated, some of which are going to be sensitive to us. So the question is, how do we stop this? Well, this is really about what the talk is about today. Artificial intelligence. We have to figure out how to crack the code. The question is, what is that code? Here's a really simplistic representation of a language model. Basically, we have an input X. We have this model, this function that we feed it into, and then we get an output. Simple, right? The question is, what is in this Pandora's box? And there's been a lot of talk about this the last 2.5 years since the release of ChatGPT. Until today, we actually still don't know. It's a big mystery to us because, in my personal opinion is that we don't have the language to describe what's happening within these neural networks. So what do we get? We get our little Shoggoth monster. It's actually the pretty face that is the representation of all of our UIs, but it's really the unknown of what it's hiding in the background. So there's a lot of issues with our little friend. The question is, whose ground truth are we grounding to? Where is the data coming from and how are we training them is the question. You are a cybersecurity community. You know that AIs today are deceptive. They can gaslight you. They hallucinate. And they're really unpredictable and unwieldy. So the question begs, are some problems unsolvable? Are these all related to some master algorithm that governs them all? For you computer science majors out there. Is it undecidable, like the halting problem? When we convert our representations, whether it's text, audio, visual, into ones and zeros, is that enough to describe what's going on? So for many years, we have been playing games. The core of the issue of what we're dealing with is actually we have to understand the exponential solution space. That is what we're grappling with all of these problems. If you look at the simple opening move of a chess game, the first move, there are 20 different types of moves that you can make. The second move, there are 400 possible moves that you can make, and it exponentially grows. So the question is, can you figure out a defense for 8,000 different types of moves after 3 rounds? And that is the impossibility and the challenges of what we're dealing with. So is AI safety an illusion? You will attend other presentations here at this conference, and they will have controls. They will have AI controls, they will have cybersecurity controls, and the question is that, can we control these risks? The answer is very fuzzy because from a technical perspective, we have ones and zeros, we have technology that can probably stop it. The part that we cannot cover with our technology, it's actually the emotional connections that these AIs are going to produce. Our human lens, it's flawed. So we were talking about chess. And what's really interesting is that humans are very predictable. This is a graphic of common opening moves that champion chess players typically make. And what's funny is that it's concentrated to just the set in this sea of complex space. And we think we could defend against this. But in reality, we're just, our side of the problem is actually flawed. So at the moment, I can make a bold statement that there is no solution to controlling these LLMs anytime soon. I am sure that many of you have had a field day. We actually have a hacking village to actually jailbreak. We know that the problem is so big that Google just came out with a paper about how do we govern artificial general intelligence. There are talks out there that basically say that the government knows that this is coming, and they're going to continue to get smarter and more capable. So there's a big field for, I know that we all love NIST, and that's how we practice our frameworks. Adversarial machine learning, they just came out with a taxonomy. I actually do encourage you to start following that. Up here, what you're really seeing is you're really seeing the early days And when I say the early days, it's just a few years ago, in a sense, of how we can take an image, perturb the data, feed it into the LLM, and have it be misclassified. And that's what we can do time and time again. But if you think about red teamers, they have a whole arsenal of things that they can throw at these things. So the question is, how do you defend against that? This pretty much sums it all. AI safety today. We're basically not equipped at the moment to actually handle these systems. Yeah, we're bringing a gun to this fight, but we're dealing with something that's different. So I want to spend a little time, because I know I only had 30 minutes for this talk, and I do want to open it up a little bit for discussion. We all know that within the industry, Anthropic has been leading the cause with a lot of the safeguards and the safety system. This is a paper that's very compelling, actually. It just came out. And what they're kind of doing is they're kind of combining the worlds of cyber. So as you can see, they use red teamers. They actually gathered their data. They created more synthetic data to actually fine-tune their safety models. This is really a depiction of what's happening behind the hood, but there's actually more to this. If I had an hour, we can dig into this a little bit more. It actually first starts with a taxonomy. Anthropic calls it a constitution. So that's a really interesting word, because constitution means that it's believed by somebody, some entity. So the question is, the constitution that they put together, who does it align with? But they actually do have a hazards taxonomy, and this is how they approach to safeguarding the models that you use. What's really interesting is that when we use ChatGPT, when we use these applications, it's just not one model that we're working with anymore. There's actually an ensemble of many models that are behind the scenes, that are orchestrating what you input into their system. So what they have come out with, they have come up with basically smaller models to actually filter your inputs based on their safety training, based on the Constitution. They can actually offer a rejection if that input is bad. If it isn't, it gets to pass into the neural network. The output is also scrutinized. There's actually another output filter that's basically an LLM that basically filters the output. And this system has to work seamlessly to not only give you the speed of inference, but also to have the ability to hallucinate less. Now, I'll talk a little bit because just this past day, we've heard some rumblings about GPT-5. It's coming. And GPT-5 it starts out as a base model. And if you're an evolutionist, all of the models that we use start with a base model. and then we fine-tune it, we instruct-tune it, and then we eventually steer it to a point where it's useful for us. But it starts with a base model. GPT-5, I am pretty sure that they spent billions and billions of dollars training this upcoming model that foreseeably will be released this year. And what I heard is that it does hallucinate less out of the box. Now, if you guys haven't noticed, because we are sort of like frogs in this boiling water, so we've been using these chatbots for like 2.5 years, and I'm not sure if you've noticed, but we have less hallucinations. And if it is hallucinating, you are probably using the wrong model, or your prompt sucks. So this is my daughter. She is gonna probably take over my embodied work when she grows up. So that was my talk, but I wanted to save a little time to kind of dig into it because I think I threw a lot at you, and I'm wondering if you guys had any questions. Yes?
Do you know of any metrics for measuring AI safety that are real?
Yeah, so in the world of AI, it is all about benchmarks. We are up to our neck in benchmarks. The question is sometimes, what benchmark should I trust? So my answer is that as soon as a model gets released, understand what benchmarks were used to actually measure that LLM. Now, I'll actually speak in general. There's an arena. There's an arena leaderboard that basically measures the performance of these models. There's actually one for safety. The problem is with these benchmarks is that if you think about these benchmarks, it is sort of like our education system. We have always measured ourselves against these tests. And it's really rote memory in a sense. They're flawed. So there's this new test that is sort of like the North Star. They just came out with the second iteration of it. It's called the ARC-2 challenge. And what it tests these language models on, it's really about skill. Because, if you think about what we want to do with these models, it is less about knowledge because we have access to knowledge from every parts of the world. The question is that, does it have the skill to actually take the knowledge that it learns and retrieves and do something with it? And that kind of feeds into like the reasoning, the planning. But the answer to your question is that there's a lot of safety models that are open source, and tied to them are benchmarks on safety. Any other questions? You first.
So I've seen plenty of input harmful filters.
Yeah.
Are any other models besides Anthropic using an output filter as well?
Yeah, so you will see a lot on Hugging Face. You'll see a lot of permutations. I know that LlamaGuard is a very popular one that that people use if you're a model builder. I know that Microsoft just came out with their Gemma, and there's actually a safety guard by Gemma and a really nice ecosystem there. So that is what's being used. The issue is that a lot of these models are distilled from larger models. So, like if you think about what they're doing with these input filters and the output filters, there's a tax on this. In this paper, they kind of outlined there's a 27% increase in costs to actually have these safeguards in place. And that could be costs that will be passed on to your consumers. That will be costs that will be, of course, impacting performance from an inferencing perspective. Yeah.
Is there anything vision related? This all seems like LLM focused.
Yeah. So in terms of vision, I'm actually working with an open research group. Vision is really tough because if you think about vision, picture is worth 1,000 words. If you think about the newer models that are released, they're vision native. So it's actually one model now that can basically, it can basically take text, images, and also it will, we have video right around the corner. So there's a taxonomy. There's a lot of taxonomies that are trying to address that. The issue is that, and I'll share a short story. I was actually working last year with this open research group, and there were these representatives from Meta. And at Meta, they have these content moderators in a sense. The hardest thing about working with these open groups and figuring out a way to, let's say, classify if an image is safe or not, is to agree on what's safe or not. We spent weeks and weeks and weeks to not try to offend anybody, to try to put some justification into what we believe safe is and what is safe. Because safety here in the US is different than what safety is in other countries. When I got into my line of research, I always knew that we're probably going to have regional models that are going to be specifically built and customized for their use and for their region. There's no universal model that's going to satisfy everybody's needs. So that's my take on that. Any other questions? Thank you. And you can follow me on LinkedIn.